As a serene afternoon slipped into evening, a routine flight over China's rolling landscapes unraveled into an airborne nightmare. Without warning, China Eastern Airlines Flight 5735, a Boeing 737-800 cruising at 29,000 feet, plummeted sharply as if caught in an invisible force's vice grip. In an era dominated by advanced aviation technology and meticulous safety protocols, how could an aircraft suddenly defy its engineered promise of safety and reliability? The skies held their breath as they witnessed one of aviation's most unfathomable freefalls, a mystery that would soon cast shadows over the hearts of millions and the peace of families left behind. In the modern era of aviation, where advancements in technology have significantly reduced the number of in-flight incidents, the sudden plunge of China Eastern Airlines Flight 5735 was an anomaly that sent shockwaves through the aviation community. The aircraft, a Boeing 737-800, was one of the most widely used and trusted models in commercial aviation, having logged millions of safe flights worldwide. Its track record carried an implicit promise of safety, bolstered by rigorous maintenance standards and state-of-the-art onboard systems designed to handle various flight scenarios. Yet, on March 21, 2022, these assumptions were challenged in dramatic fashion, raising alarming questions about inherent vulnerabilities in the aviation sector. The 737-800 itself represents an engineering marvel, with its design refined through decades of aerospace advancements. It embodies a balance of performance and reliability, with systems that include multiple redundancies meant to ensure passenger safety. For many, air travel is synonymous with the kind of predictability and control unmatched by other forms of transport. Pilots undergo extensive training, and aviation protocols are stringent, leaving little room for error. Yet, the inexplicable behavior of Flight 5735 called these elements into question, as it began an unrestrained descent, defying the very purpose of its sophisticated systems and protocols. When Flight 5735 took off from Kunming heading for Guangzhou, everything seemed routine. The initial phase of the journey followed established routes and procedures, and the aircraft maintained a consistent altitude, signaling a typical uneventful flight. The Boeing 737-800, equipped with advanced avionics capable of providing real-time data to pilots and ground teams, transmitted normal readings until it didn't. In an instant, the plane shifted from its cruising altitude and entered a plunge that bore no preliminary mechanical distress signals or apparent external influences like severe weather conditions or air turbulence. The perplexing descent of the aircraft unfolded in a matter of minutes, a period during which air traffic controllers and ground engineers would have scrambled to understand what was happening. The vertical dive at such a velocity and trajectory emphasizes an extraordinary event, one that aviation safety measures are specifically designed to prevent. The suddenness and the severity of the descent suggested an acute failure or unexpected input, either mechanical or manual, compelling experts to launch a full-scale examination of every conceivable factor, from potential software errors to unauthorized cockpit actions. These events reignited discussions on the reliability of existing safety protocols and highlighted the perennial challenge of accounting for every variable. The aviation sector is supported by a comprehensive network of international safety guidelines. But instances like Flight 5735 remind us that even the most minute oversight can have catastrophic consequences. This has prompted reassessments within the aviation community and emphasized the common understanding that no system is impervious. While the cause of this tragedy was still being unraveled, initial conjectures pointed towards the potential role of cockpit interactions, fueling further investigation into the human elements of flight management. The incident's unexpected and dramatic nature put a spotlight back on airline safety standards, underscoring that high expectations alone aren't a guarantee against the unpredictable nature of human factors or anomalies in the engineering matrix. As the investigation continued, the next phase was to dissect the precise moment when the Boeing 737-800's trajectory radically shifted, seeking clues within flight data and cockpit voice recordings. This would eventually bring the narrative to the aircraft's plunge from its stable altitude, deepening the quest for answers. The transformative moments of Flight 5735's journey unfolded abruptly and violently, marking a drastic shift from equilibrium to catastrophe. Up until that pivotal moment, the aircraft had maintained a cruising altitude typical of its journey across the skies of southern China. This is where aircraft traditionally operate optimally, moving forward with remarkable steadiness, thousands of feet above any potential obstruction or turbulence. Flight 5735 was no exception to this norm, until suddenly it was. At roughly 2:20 p.m. local time on March 21, 2022, the Boeing 737-800 inexplicably began to deviate from its set path, descending with an acceleration that stunned both air traffic controllers and aviation experts worldwide. The initial seconds of the descent provided little indication of the severe trajectory the aircraft was about to take. What was initially perceived as a minor altitude correction quickly transformed into an alarming vertical drop, revealing the uncontrollable nature of the situation. Within minutes, the aircraft jettisoned from its designated flight path, violating the expectations of a typical descent procedure. The speed of the descent suggested an uncontrollable plummet rather than a controlled descent, amplifying concerns and confusion. As the aircraft rushed toward the ground, the velocity achieved was nothing short of catastrophic, suggesting that whatever had initiated the descent had rendered the pilots and the autopilot systems non-functional or ineffective. This steep and rapid descent is an aviation nightmare, a stark contrast to the precise controls typically exercised in modern air travel. Throughout this harrowing episode, repeated attempts to engage with the crew reportedly went unanswered, compounding concerns about possible incapacitation or equipment failure on board. Flight data transponders, providing real-time altitude, speed, and other critical flight metrics, indicated a descent at rates far exceeding normal operational limits. Such an intense downward acceleration is usually not seen unless an aircraft is experiencing a dire emergency, whether mechanical, structural, or human-induced. The focus on data, particularly from the flight's black boxes, the Flight Data Recorder, FDR, and Cockpit Voice Recorder, CVR, has become all the more critical in this context. Yet even here, the information, while crucial, initially sowed more questions than answers. Investigators looked hard at this descent phase. Was there an error in instrumentation that provided incorrect altitude or speed readings to the cockpit? Had any warning alarms malfunctioned or failed to alert the pilots in time? Adding another layer of complexity to the situation were eyewitness accounts from the ground, reporting a drastic, almost vertical fall of the doomed aircraft. Locals described seeing the plane nosedive at what seemed like uncontrollable speeds, a view corroborated by security camera footage captured from nearby buildings. This footage, paired with data charts, presented a haunting visual narrative that filled the gaps of what unfolded at 29,000 feet. As the investigation continued, the challenge was to decode every line of data and every second of cockpit conversation to reconstruct those final, fateful moments. The trajectory of this narrative would next examine how exactly the aircraft met the Earth in such a violent manner, as aviation data subsequently confirmed a near-vertical impact, leaving behind a crater indicative of its final, destructive speed. This would open the pathway to understanding the mechanics of the crash itself, examining impact patterns, debris spread, and structural disintegration upon contact with the ground. In the aftermath of the devastating plunge of China Eastern Airlines Flight 5735, the stark imagery of the aircraft's final moments became etched in the annals of aviation history. A Boeing 737-800 hurtling towards Earth at catastrophic speeds, leaving onlookers and experts grappling with the magnitude of the disaster. The flight, previously cruising through serene skies, ended abruptly as it nosedived from an altitude of 29,000 feet, culminating in a near-vertical impact that was both rapid and unyielding. Data extracted from the aircraft's black boxes painted a harrowing picture that challenged even seasoned investigators with its abruptness and gravity. Upon analyzing the flight's final trajectory, aviation experts observed that the aircraft's descent was not only unprecedented in its angle, but alarmingly fast. A typical descent, initiated during normal flight operations, is calculated and controlled to ensure safety over time and distance. Flight 5735, however, defied these parameters, plummeting at a rate suggesting something had gone catastrophically awry. As the Boeing approached terminal velocity, any potential for recovery from such a steep angle of descent diminished, devastatingly bearing out the fears of those monitoring the flight's path from afar. The crash site provided tangible yet heart-wrenching evidence of this violent end. A deep crater at the impact location bore silent witness to the ferocious speed with which the aircraft met the ground, shredding the plane to fragments scattered over the landscape. Forensic teams immediately began sifting through the debris over an expansive area, methodically collecting parts to reconstruct the final phases of the flight. The search was complicated by the varied terrain and the sheer force of the impact, which had devastatingly compacted essential evidential materials into unrecognizable forms. Witness accounts from those nearby provided chilling corroboration. Residents recounted seeing an unnatural flash of metal plummeting earthwards, a spectacle reminiscent of disaster movie scenes rather than real life. Security footage from surrounding areas captured these final seconds in sequences that have since been replayed countless times by investigators striving to pinpoint every anomaly. This material, combined with the physical state of the wreckage, solidified the reality of the near-vertical dive, a characteristic that added urgency and profound complexity to the ongoing investigation. The steep angle of descent posed significant questions about potential causes, from mechanical failure to human intervention, necessitating thorough, multifaceted investigations. As aviation teams delved deeper into the flight data recorder, FDR, and cockpit voice recorder, CVR, every spike, dip, and fluctuation in data had to be meticulously analyzed, leaving no stone unturned in the search for plausible explanations. This analysis spanned various factors: autopilot settings, mechanical signals, and possible pilot inputs, or the lack thereof, all filtered through the lens of experienced aviation professionals worldwide. The abrupt end to Flight 5735, coupled with its destructive dive, pushed global aviation bodies to respond swiftly and comprehensively. The immediate focus was on preventing such an incident from repeating, with experts stressing the rarity of such an acute event. This catalyzed an international dialogue about both the technological robustness and vulnerabilities inherent in even the most advanced aviation systems, prompting a reassessment of safety measures and communication protocols, not just in China, but across the global aviation network. The narrative would soon shift to these international responses, emphasizing the collaborative urgency to uncover not just how the crash occurred, but how to prevent an equivalent tragedy in the skies above us. In the immediate aftermath of the China Eastern Airlines Flight 5735 crash, a global response was mobilized with unprecedented speed and precision. The aviation community, bound by a shared commitment to safety and understanding, quickly galvanized resources and expertise in reaction to the shocking rarity and severity of the incident. The gravity of the accident was felt on a global scale and showed the resilience and preparedness of international aviation networks, which sprang into action to address the urgent need for answers. The rarity of such a catastrophic event among modern commercial aircraft spurred experts worldwide into high-stakes collaboration. Initial assessments conducted by the Civil Aviation Administration of China, CAAC, alongside Boeing engineers and seasoned investigators from the U.S. National Transportation Safety Board, NTSB, set the stage for an intense and expansive inquiry. Their immediate focus was on stabilizing and securing the crash site to preserve crucial evidence that could illuminate the path to understanding. International aviation experts emphasized the unprecedented nature of the crash, prompting an urgent examination of all available data. This incident posed a significant anomaly when compared to the tenacious safety record of aircraft like the Boeing 737-800, a model that underpinned countless safe flights across the globe. Each anomaly captured by the plane's flight data recorder and cockpit voice recorder was a puzzle piece reiterating the accident's exceptionality. This invited deeper scientific scrutiny as potential leads were pursued comprehensively. from mechanical assessments to environmental factors, potentially affecting the aircraft mid-flight. Simultaneously, aviation safety organizations worldwide, at the behest of consumer protection agencies, recommended a systematically heightened review of Boeing 737 models' operational frameworks across different airlines. In parallel, aviation authorities canvassed their records for any historical precedents that could clarify or parallel Flight 5735's fate. This historical sweep went beyond model-specific incidents, including rare phenomena and anomalies that could shed light on unexpected patterns or oversights. On-the-ground investigations progressed rapidly, marked by meticulous attention to every fragment recovered from the crash site and every digital imprint retained within the plane's recording devices. Aviation teams worked diligently, combining rudimentary detective work with complex simulations to reconstruct the events of that ill-fated afternoon. Experts meeting with local and international media underscored the accident's singular nature, fortifying the pressing necessity to delineate its specific causes, pursuing plausible theories from structural failures to deliberate actions that might have gone unaddressed in previous safety audits. The urgency of such a response reflected profound concerns within the international community about maintaining public trust in air travel. Aviation remains one of the safest transportation modes, but incidents like Flight 5735 remind industry leadership of vigilance is imperative. The swift coordination among airlines, manufacturers, and safety boards underscored how deeply the knowledge and insights from this investigation could inform future policies and technological advancements, paving the way for even higher safety standards. As the investigative efforts deepened, the focus shifted to potential causative factors, compelling investigators to reference peculiarities from prior accidents and possible discrepancies in the cockpit, areas laden with both challenge and controversy. This development set the scene for examining each contributory thread, exploring how human actions, technological systems, and environmental variables interwove in those fraught final moments to potentially precipitate such an extraordinary crash. The tragedy of China Eastern Airlines Flight 5735 spurred an in-depth investigation of unprecedented breadth and intensity. As forensic teams combed through the wreckage, experts from around the world converged to decipher the enigmas etched into the few remnants of data. The investigation was characterized by a methodical approach that employed advanced technology, historical precedent, and human expertise to unravel the potential causes of such an unusual aviation disaster. The search for answers was a puzzle complicated by both the immediacy required for public reassurance and the technical challenges involved in scrutinizing every aspect of the flight's ill-fated final moments. Central to the investigation was an exhaustive analysis of data captured in the Flight Data Recorder, FDR, and Cockpit Voice Recorder, CVR. These tools are invaluable in aviation investigations, catching every nuance in the aircraft's performance and the crew's interactions. Designed to be indestructible, their retrieval and subsequent analysis were paramount. Interrogating the recorded parameters, ranging from engine performance to cockpit conversations, became crucial. Investigators pored over this information, assessing the intricate dance between mechanical systems, software controls, and human inputs to discern any irregularities that might explain the trajectory taken by Flight 5735. Historical aviation anomalies served as vital reference points throughout the inquiry. Previous incidents involving unexpected aircraft behavior provided case studies that could potentially illuminate the peculiarities of this tragedy. The investigation team examined rare scenarios from the archives: mechanical failures that slipped past maintenance checks, miscommunication between cockpit crew and instruments, and even calculated sabotage. Each scenario was dissected for parallels that might match the data signature left by Flight 5735. Also noteworthy was the focus on the Boeing 737-800's previous incidents. Although generally lauded for its safety record, it wasn't immune to scrutiny. Past anomalies, such as those resulting from software glitches or component failures, were revisited. The goal was to ensure no stone was left unturned in determining whether an overlooked flaw contributed to the catastrophe. Notable were discussions surrounding the plane's autopilot controls and potential conflicts this might present under rare in-flight situations. Simulations and recreations were vital components of the investigative toolkit. By replicating potential mechanical and environmental conditions in a controlled setting, experts could test hypotheses around the aircraft's behavior during its last moments. Investigators considered everything from sudden shifts in aerodynamic forces to hypothetical electronic malfunctions. The intricate dynamics of aviation engineering invited investigators to apply cutting-edge technologies, using advanced computational models to replay the accident in virtual environments. Still, amid this technical barrage, the human factor loomed large. Assigning blame would require carefully deducing whether human error, within the cockpit or beyond, had played a role. This reflected the need to piece together the pilot's decision-making processes in those critical last minutes. Historical precedents underscored that even the most experienced crews were subject to rare misjudgments under duress. Thus, examining pilot credentials, schedules, and health were integral to understanding any internal pressures or lapses that could have contributed to the incident. As these exhaustive investigative steps unfolded, subtle data discrepancies began hinting at the cockpit as a focal point of interest. Echoes from prior strange cockpit behaviors in aviation history intensified this possibility. Such anomalies were not only statistical blips, but potential key markers in exploring whether crew actions or inactions intersected with technological limits to trigger such a descent. This investigation phase seamlessly segued into an examination of possible cockpit involvement, driven by curiosity and driven by the invitation to unpick the complex web of interactions that prefaced the aircraft's tragic fate. As investigators delved deeper into the data retrieved from the wreckage of China Eastern Airlines Flight 5735, preliminary insights began to point towards potential anomalies within the cockpit itself. Among the primary sources of this suspicion were discrepancies in the flight data that suggested abrupt and unexplained inputs, alongside voids or incoherent segments captured by cockpit voice recordings. These anomalies created an intricate puzzle, raising the specter of either human error or interference that might have played a role in the aircraft's sudden and tragic descent. The cockpit, as the beating heart of the aircraft, is a microcosm of the broader aviation environment. It is where technological systems and human judgment intersect to navigate the aircraft safely from point A to point B. In the initial stages of analysis, certain recorded data seemed to deviate from expected norms, inviting a closer examination of the flight crew's actions and interactions. For investigators, the key questions involved whether these deviations were due to legitimate responses to a preceding failure or somehow contributed to the catastrophic outcome. Aviation historians and safety experts have long noted that cockpit operations can become fraught under duress, oftentimes bringing human factors into sharp focus. Traditional scenarios, such as pilot miscommunication, misinterpretation of automated systems, or unintended inputs due to fatigue or distraction, were all considered. With Flight 5735, the opaque nature of some events captured in the CVR led investigators to explore these avenues. Could an inadvertent error have been compounded by technological lapses, magnifying the effect into a full-scale calamity? Adding layers to these considerations was the profile of the flight crew, both seasoned professionals by all accounts, subject to routine evaluations designed to uphold the stringent standards of air safety. In every investigation, such factors form part of the intricate forensic process aimed at piecing together not just the sequence of actions, but the motivations and conditions underpinning them. This investigation saw review panels scrutinizing personnel records, past performance, and the dynamics within the cockpit environment to understand what might have precipitated or failed to prevent their response to whatever situation occurred mid-flight. Data anomalies drew parallels with historical incidents where cockpit misjudgments or interface misunderstandings played roles. In some cases, assumptions ingrained in routine practice under unfamiliar scenarios led to tragic outcomes. Therefore, experts examined if unforeseen cockpit dynamics mirrored any past anomalies, where either panic or misplaced reliance on automated systems had caused distraction or a momentary lapse in judgment. The importance of cockpit environment extends beyond technical competence to effective communication. Evaluating any clues of stressors or compelling background unheard within CVR gaps was critical. Was there evidence, overt or covert, of internal strain, operations under duress, or even deliberate inputs pointing to a broader crisis? Investigators treaded carefully, knowing each theory held implications for wider perceptions of crew competency and sector standards. These preliminary data discrepancies emphasize the need for a rigorous audit of cockpit protocols and pilot support systems. The international aviation community, incessantly striving towards achieving error-free flying, engages in ongoing refinement cycles with each learned incident. Insights gleaned from this cockpit-centric investigation promise to contribute significantly to evolving methodologies, highlighting potential enhancements in data symbiosis and pilot interface technologies. Ultimately, uncovering what happened in the cockpit of Flight 5735 could guide future safety protocols and training procedures, ensuring that both technology and its human operators can respond more cohesively in critical situations. As this chapter sets the stage, the broader aviation community turns its attention to examining existing safety protocols and communication systems, poised to learn from the ongoing revelations in the quest for ever safer skies. In the wake of China Eastern Airlines Flight 5735's catastrophe, the global aviation community was once again compelled to examine the robustness of its safety protocols and communication systems. Such scrutiny arises whenever an accident of this magnitude occurs, challenging assumptions, uncovering weaknesses, and championing innovation in the pursuit of enhanced safety. The margin for error in aviation is virtually non-existent, and the reverberations of this disaster have placed a renewed focus on systemic improvements that could prevent future tragedies. International aviation safety protocols have long been regarded as among the most stringent regulatory frameworks in any industry. Built on layers of preventative measures, these protocols are designed to anticipate, mitigate, and manage virtually every conceivable scenario. However, the grim lessons of past accidents assert that complacency can never take root. The aftermath of Flight 5735 accelerated discussions amongst regulatory bodies, including the International Civil Aviation Organization, ICAO, the Federal Aviation Administration, FAA, and the European Union Aviation Safety Agency, EASA. These discussions emphasized an immediate need for reflections and revisions on established processes. Central to these conversations was the role of technology in both problem-solving and problem-creating scenarios. As aircraft have become more sophisticated, the potential for technical system failures, underscoring human limitations, is a recurring theme. ACES into cutting-edge sensor tech, automation systems, and pilot interface tools became critical. Aviation technologists considered how integrated tracking and warning systems could improve cockpit alertness, facilitating real-time problem recognition and resolution. The imperative is not merely to refine existing infrastructures, but also to anticipate future intricacies that might emerge from rapid technological evolutions. Communication systems, which underpin successful responses to in-flight emergencies, also came under intense scrutiny. Effective communication is pivotal, not solely between cockpit crew members, but among air traffic controllers, ground support, and inter-organizational networks. Post-Flight 5735, proposed enhancements involved not only improving technical bandwidth and reducing reliance on potentially fallible components, but also fortifying training programs that emphasize clear, concise, and accurate information transfer during emergencies. Language barriers, temporal delays, and ambiguous protocols can exacerbate stressed scenarios. Addressing these gaps involves revisiting the protocols that govern coordinated efforts across teams and territories, ensuring seamless transference of both critical data and responsibilities. A significant dimension of the dialogue also revolved around human factors engineering. Continuous pilot education, recurrent training exercises, and a profound understanding of human capacities and limits form the backbone of successful flight operations. These discussions reached into the domains of fatigue management, stress testing, and cognitive workload analysis, proposing enhanced methodologies for assessing how pilots interact with complex automated systems under duress. Bridging the gap between human operators and machine intelligence remains an enduring objective in achieving safe, reliable flight. The global aviation community, buoyed by its resilience and compelled by its dedication to safety, thrived on the pressure of safeguarding future flights from similar calamities. This period of introspection and innovation aspired to translate the heartbreak of Flight 5735's aftermath into constructive, life-preserving outcomes. As industry leaders forged a path forward, drawing not just on technological innovation, but incorporating lessons from past events, anticipation grew for the future directions of these revamped safety protocols. As these industry-wide enhancements were meticulously planned and tested, investigators turned their focus towards collaborative efforts between America and China, emphasizing how cooperative frameworks bolster both investigative processes and future safety innovations. This step underscores a shared commitment to elevating standards and ensuring that the lessons learned from Flight 5735 are woven into the fabric of an ever more secure air travel network.